Hello students, welcome back to chemistry online class brought to you by Hayato Virtual Learning Platform. I am still your tutor, Olabisi Olawaye, and today we'll be treating the second part of the kinetic theory of matter, and that is the changes of state of matter. And I want you to pay attention to the end of the class, because at the end we have past questions selected based on this topic, and it will be I promise it will be an interesting class. And don't forget that these questions are actually selected from WAEC syllabus, and it should be useful for your examination. So I want you to subscribe to this channel, share to your friends so that they can also benefit from the class. The first topic here is changes in the state of matter. Now, in the last or previous class, I told you that when you increase the temperature of a substance, the particles of the substance, like solid, liquid, or gas, the particles are loosened and they are free. And this is actually achieved based on the temperature. Whenever the temperature of a substance is increased, the particles are free and they are released. So, changes of state is achieved anytime there is a change in temperature. If there's a drop or reduction in temperature, a state of a substance can change. If there's also an increase, the substance can also change. Now, a given substance can exist as a solid, liquid, or gas, and the change of state is brought about by a change in the temperature, heating or cooling. So when such substance is heated, its particles acquire kinetic energy. When they are cooled, they become less energetic. So therefore, if impact of temperature is that increase in temperature leads to increase in kinetic energy, which also leads to increase in collision. So, and vice versa. So here with me, I have the structures of the solid. What a solid look like. Solids around us can be furnitures, books, phones, anything that has mass and occupies space, and they have definite shape. So we can see this the particles of solid here, they are held together in a fixed position, and they have a fixed mass. These are their properties. Then the particles only vibrate. They can only vibrate and rotate about a fixed position. Now we see here that they have fixed shape. Solids have fixed shape and fixed volume. They do not take the volume of their container. They have their own volume, and they have their own shape. And they are incompressible. We cannot compress them because they are very, very heavy or very dense. That's one thing about solids. And some solids, or most solids, have high melting point. That is requires a very high temperature to melt them. Now, how do we now explain more using the kinetic theory of matter? We could see here that in a solid, the state of disorderliness or randomness is very, very low. So the particles are well organized, and they are not disordered. So we can say that the randomness or entropy, which is a state of disorderliness or randomness of a body, is very, very low in solids. And what's the implication or the impact of increasing the randomness or disorderliness of a system? When particles of a substance, of a matter, whether solid, liquid, or gases, are in a state of disorderliness, we see that collision occur easily, and then reactions take place. That is, I'm going to refer you to collision theory, that there must be effective collisions before reactant particles can form a product. So we could see here that when particles of substances are in a state of disorderliness, they tend to collide with themselves, with causing more collisions and then forming new substances. And also, when you are writing chemical equation, we know that there is a kind of rearrangement of bonds, and when we are getting the product, the reactants react together to form product. So there's a break of bond, there's rearrangement. So that's what takes place in reactions for new substances to appear. The particles of the old substance must break away from each other and must realign with other particles. So in solids, there's a decreased disorderliness. In liquids, you can see here that liquids does not have a fixed mass. They do not have a fixed shape rather, and they do not, they have volume, but they do not have a fixed shape. They take the shape of their container, and they also vibrate, they rotate, and they move about, their particles move about a restricted space. The particles are only slightly free from each other, and that's why they flow. They collide with themselves within a restricted space. They cannot be compressed as well, and they are less dense than solid, except in water, which has more density than iced form of water, or the block form of water. Now, liquids tend to have weak forces holding their particles together. There is a weak intermolecular forces holding them. That's why the boiling point of liquid is not as high as that of solid. And then the degree of randomness or disorderliness is very, very low. Is very, very high compared to that of solids, but low compared to that of gases. The particles are also in a state of disorderliness, but it actually decreases compared to that of gas. And looking at that of gas here, you can see that the particles of gases are very, very free, and they occupy free space. And these particles are loose. That's why when you open a container of perfume, you perceive the odor at the other end almost immediately, because the particles are always in constant motion, moving about, and moving speedily. And so gases have fixed mass. Their particles move about constantly at great speed and at random. So the degree of disorderliness is very, very high, and randomness increases in gases compared to liquid and compared to solids. They do not have a fixed shape, they do not have fixed volume, and they can be compressed. You know, gases can be compressed, they can be forced inside a cylinder. Gases can be forced inside a cylinder, and they are the least dense. They are not as heavy as liquid and solid. Now, that leads us to the explanation of the changes of state of water. We're going to be considering water, iodine, naphthalene, and also sulfur to explain the change of state. Don't forget I said that change of state is brought by changes in temperature. Now, the first aspect here is the cyclic nature of water. Water exists in three states. Water can be in form of solid, it can be in form of liquid, and it can be in form of gases. Now here with me, I have the various structure. Permit me to make corrections to this. The particles of solids here, this is represented as solids. The particles of solid are here, then that of liquid is here, and this is the one of gas. This is assumed to have least particles. This is the liquid, this is the solid, and this is the gas. We can see here that a solid water is represented as ice or ice cubes or block. That of liquid is the ordinary water that we all know at room temperature. Then gas is the vapor or the boiling water, which is the steam. When we are boiling water, the steam that comes out, that is water in gaseous form. Now, what are the changes of state that exist between exist in water or in the different forms of water? Now, when a liquid is boiled, when it reaches its boiling point, it will begin to evaporate. That is, the vapor pressure will begin to the vapor will begin to escape from the water. At that point, you see that the boiling point is already reached. the particles are escaping, the most energetic particles are escaping into the atmosphere. That's in form of vapor, which is a gaseous state. So at that point, we can see this arrow pointing at evaporation. Water can evaporate when heated and it will change to gas. Now, when this vapor that is escaping is trapped inside a condenser, is not allowed to escape, and there is a drop in temperature, it can actually cool down and the vapor or the gas will form back a liquid. And that explains why rainfall also exists. Evaporated water from the surface of the earth goes into the sky and then they form the cloud. Then when there is a kind of drop in temperature, this cloud or the water, evaporated water here, condenses and fall back as rain. And so whenever there's a drop in temperature, condensation takes place, and whenever there's an increase in temperature, evaporation takes place. Now let's look at this, the relationship here between gas and solid. Or first, let's look at that of solid and liquid. Now, between a solid and a liquid, look at where the arrow is pointing out. If there's a change from solid to liquid, that is melting. Now, a solid begins to melt and form a liquid whenever there's an increase in temperature. For instance, margarine can be melted to form oil. Ice cubes or ice block can be melted. That's the state in which water exists. Ice cubes can be melted when exposed to high temperature and it will turn to water. Now, whenever there's a drop in temperature, reduction in temperature, which is usually created in freezers or refrigerator, where there is a very, very low temperature, and even the negative values, you know that there is a low temperature and then freezing can take place. At that point, the liquid is changing back to solid because the particles are less free. They are not gaining kinetic energy again. They are settling down and then they are changing back to solid. But in the state of evaporation and condensation, in evaporation, there is an increase in temperature. The particles are excited and they are changing to gaseous state. And then when there is a drop in temperature, the particles lose energy and they begin to settle down to form liquid back. That is condensation. Now, at this point, when a solid is also heated, there are some states in which the solid changes directly to gas without passing through the liquid state. At that point, we say the substance is sublimed. That is sublimation. That is, but that does not take place in water. So to say, water does not sublime. I'm just using this as an example that some solids like iodine, naphthalene, ammonium chloride, when heated, they can change directly from solid to gas. This is just used to explain the reactions that take place. Whenever there's an increase in temperature, they change directly from solid to gas without passing through the liquid state. And there's another reaction too between gases and solid. Some gases actually can be deposited. They accumulate and after some time they turn to solid. And in that case, we say they are being deposited. That is deposition. Deposition. This does not actually, this side does not really reflect the cyclic state of matter, the cyclic state or nature of water. Deposition and sublimation is not part of this behavior of water. But what I'm trying to say is that water can exist in different forms, can exist in solid, liquid, and also in gas. When water changes from liquid to gas, we say it's evaporating. And when it's changing back from gas to liquid, it's condensing. When water changes from solid, that's ice cubes, to liquid, it's melting. And when it's changing back from liquid to solid, it is freezing. Whereas other substances also sublimes. They change directly from solid to gas. And gas is also changed directly from gas to solid. That is deposition. While from solid directly to gas is sublimation. This does not account for this is not part of the characteristics of water. This is only used to explain that other solids also does this. Solids like iodine, naphthalene, ammonium chloride, they sublime. And that is the next part we are also treating, which is sublimation. Now, there's a change of state in iodine and naphthalene. Actually, whenever they are heated, they sublime. Even when they are not heated, iodine, when you expose iodine solid to the air, it begins to change state because of the changes in temperature of the room temperature. Is beginning to vaporize, and then you'll be seeing vapor or drops of iodine, which has a characteristic purple color. You'll be seeing it around you. It shows that it changes state directly from solid to gas or vapor without passing through the liquid state. So this is just a way of representing them. A solid change to gas. Using this arrow, we have sublimation, and when the gas change to solid, we have deposition. These gases, some of them too, when they are allowed to accumulate without escaping, they can accumulate back to form solids. And iodine, naphthalene, and ammonium chloride is a very good example of change of state of a substance, the change of state from solid to gas, which is sublimation. Iodine and naphthalene is a very good example of this. The next one is the change of state in sulfur. There is also change of state in sulfur, which is also as a result of temperature. Whenever there's a temperature change, like sulfur that exists in different forms, the allotropes of sulfur, some of the crystalline allotropes are in two forms. They are rhombic sulfur and monoclinic sulfur. Now, rhombic sulfur it has a rhombic structure, and it is only stable at a temperature below 96 degrees Celsius. So anytime there's a change in temperature, it would switch to another form. That is, there will be a change of state. It will change from the rhombic structure to a needle-like structure. It will change to a needle-like structure, which we call monoclinic sulfur. Monoclinic sulfur is only stable between 96 degrees Celsius and 119 degrees Celsius. We can see that changes of state is as a result of changes in temperature. So changes from monoclinic nature back to rhombic structure occur whenever there's a drop in temperature as well. We can see that this pathway is represented using this arrow. The rhombic structure here changes back to monoclinic structure when there is an increase in temperature between 96 degrees Celsius and 119 degrees Celsius. And from the monoclinic nature, if there is a drop in the temperature and temperature is below 96 degrees Celsius, it will change back to rhombic structure, which has a rhombus shape. This accounts for the different changes in the state of matter or of different solids. So some solids actually melt and they change to liquid, while some melt, they change to gas directly without passing through the liquid state. And some liquid also change to solids directly. Then liquids changes to vapor as well. These are the various changes which we have as a result of changes in temperature. Now, over to the past question revision aspect of this topic, which is on changes of state. These are questions that have been carefully selected from past questions based on this topic. I want you to pay attention, treat this stuff, pause this video, try to attempt these questions on your own. After attempting the questions, we'll come back and solve them together. I'm going to pause the video here and then allow you to treat the questions, after which we come back for the solution. Welcome back to the past question on changes of state of matter. The first question here, name the possible states in which water can exist. That is June 2008, number 3 theory. Water can exist in solid form, liquid form, and also gaseous form. As treated on this part, we have the liquid form of water, we have the gaseous form, that's water vapor or steam. The liquid part is the ordinary water, while the solid is the ice cube or block. Now the second question, so water exists in solid, liquid, and gas. Which of the statement about gases is not correct? We are going to be applying the knowledge we had in the kinetic theory of matter here. The total kinetic energy of the gas is not affected by collision. No. Molecules of the gas are in constant motion. Yes. Then gases have low density compared to solids and liquids of equal mass. Yes, that has been treated here, where I said that gases have less density. They are less dense. They are not as heavy as solids and liquids. They are less dense. Those they do not have a fixed volume. They take the shape of their container, but they have less density. So they have low density compared to solids and liquid of equal mass. And the molecules of the gas are always in constant motion. Then gases are highly soluble in water at high temperature. Really? No, no, no. Now, one thing about gases is that when there's an increase in temperature of gases, they become more unstable. They become more unstable. So here, I think the best answer here is that we will go for is option D. The first option here, which says the total kinetic energy of the gas is not affected by collision. Actually, it is the kinetic energy that leads to collision. It is not collision that leads to kinetic energy. Kinetic energy leads to collision. Whenever there's an increase in temperature, there will be an increase in kinetic energy, which also increases the collision. So it is not the other way around. So the best answer here is gases. The option D, gases are highly soluble in water at high temperature, which is not correct. Increase in temperature decreases the solubility of gases. Now, but that can work for solids. When you increase the temperature of solids or liquids, you say that they become more soluble in water. The next option, the following statements are correct except A, energy is released when liquids change to solids. Energy is released when liquids change to solids. 2, particles move faster in the gaseous state than in the liquid state. We are asking that which one is correct, which is not correct out of these 4 options. Please always check the word except. Now, the first option here is energy is released when liquid change to solid. The second one, particles move faster in the gaseous state than in the liquid state. This is true. Carbon atoms in gaseous methane are further apart than those in diamond. Yes, methane are made of methane. This is the structure of methane, CH4, which is carbon surrounded by 4 hydrogen. Now, which can also combine with another methane. But in diamond, the diamond is the hardest substance known. The carbon in diamond are densely packed together, and that accounts for its density and hardness. They are made up of only carbon, which are tightly held together. There is no free valence electron, unlike even in graphite. So the particles of carbon in diamond are tightly held together. So this is also true. There is large decrease in the volume of a solid metal when pressure is applied to it. Is that correct? No. There is a large decrease in the volume of a solid metal when pressure is applied to it. That is, when a solid metal is being pressed down, after pressure has been applied to it, there will be a large decrease. Is this so? We have two options that are correct here, B and C. So we are to choose between A and D. So what is the best option? So the best option here, if we are to choose between the two, A and D, energy is released when liquid change to solid. Yes, it is true that energy is released when a liquid changes state to solid because there's a drop in temperature and freezing is taking place. Now, option D, there is a large decrease. Is it possible for you to press a metal by applying pressure and then there will be a decrease in the volume? No. So this accounts for the fact that solids cannot be compressed. Solids cannot be compressed. And so the odd one out is D. The statement is not correct. Which of the following statements about liquids is true? Liquids maintain their volume at constant temperature. We are choosing the best option here. 2. Liquids have mixed shape. Is that true? We are being asked about the statement that is true. 3. Liquids do not diffuse. Is that true? I don't think so. Liquids diffuse. They move from a region of higher concentration to a region of lower concentration. Next, change in pressure affects volume of liquids. So what is the best answer? Is it only one? The first option, which is liquid maintain their volume at constant temperature, or option B, which is 4, change in pressure affect volume? Is it option C, which is 1 and 4? That is, may liquids maintain their volume at constant temperature and change in pressure affect volume of liquids? And option D, which is 2 and 3, liquids have mixed shape or liquid do not diffuse. We are asking for the correct option. So the best answer here is option A, which is liquids maintain their volume at constant temperature, no matter the temperature. As in, if the temperature is constant, it's not changing, you have a constant temperature that is not changing, then the volume of the liquid is the same. It does not evaporate. But when there is a change in temperature, evaporation occurs. That is after the liquid has reached its boiling point. So other options here, liquids have mixed shape. No, they do not have mixed shape. They do not have shape at all. They take the shape of their container. And liquids diffuses. So this option that liquid does not diffuse is not correct. Then change in pressure affects volumes of liquids is not true. Whenever there is a change in pressure, the volume of liquid is not affected. They may be squeezed together, but the volume, it will be difficult to even compress a volume. It's difficult to compress a volume. So the change in pressure does not affect the volume of liquid. Liquids, so you can see that these are the properties of solids, liquids, and gases that are asked in different forms. They may not ask you to state the properties of solid, liquids, or gases, or the questions might be asked in different forms. So this is the application of the characteristics of solid, liquid, and gases. The last question here. So the best option is option A, which is 1 only. That is, liquids maintain their volume at constant temperature, while other options are not correct. Now, particles in a solid exhibit what? This is June 2018, number 50. A, vibrational motion only. That is, one thing about particles is that they vibrate in a fixed position and they cannot change form, they cannot translate. So, A, particles of solid exhibit A, vibrational motion only, B, vibrational and translational motion, C, vibrational and random motion, D, random and translational. They are not random. The particles are not random. They are not in a state of disorderliness or randomness like gases are, and they only vibrate and they do not translate. They do not change their state. They do not translate or move about. That's the meaning of translation in this case. They are not random and change and move about, colliding with themselves. That's what I'm trying to say here. And so the particles of solid are always in a fixed position, except when there's an increase in temperature, which loosen the cohesive force holding the particles together and make them gain kinetic energy, and they begin to collide with themselves. Unless that, if not, the particles in a solid exhibit vibrational motion only, that is, they don't move. So the best answer is option A. I must commend your effort as you have waited or participated fully in this class today. I want you to watch out for the next part of this topic. There's a last part of this topic, which is on a phenomenon supporting the kinetic theory, which are the Brownian motion and diffusion. Thank you for participating in this class, and watch out for the next video. Don't forget to subscribe and share to your friends so that they can also benefit from this class.